Hello, welcome to Haile Planetarium's first ever virtual star party. I'm Krista Spites, the director at Haile Planetarium, and I'll be your tour guide for tonight. We're going to start at Schneider Observatory at NKU. We're going to start tonight by looking in the southeast, where we see two bright stars that are not actually stars, but are actually planets. The brightest one is Jupiter, the other is Saturn. This is a picture of what Jupiter and Saturn actually look like in the sky. This photo was taken by Jun Lau, a member of the Cincinnati Astronomical Society, who graciously gave me permission to use some of his photos in our star party. We're going to start by taking a look at Saturn. Aren't the rings pretty? Jupiter is very bright. These four dots that you can see around Jupiter are moons. They're known as the Galilean moons, first seen by Galileo. We can see the moons in our telescopes too. It was by watching as the moons moved around Jupiter that Galileo figured out that it was possible for something to orbit a body that was also orbiting something else. The most accepted theory at the time was that the Earth was at the center of the universe and everything else moved around it. Galileo's observations of the moons of Jupiter helped show that the Sun is the center of the solar system. This was the orientation of the moons of Jupiter when I got the image on July 26th. And Europa is the moon off by itself, and then on the other side, closest to Jupiter is Io, then Callisto, and Ganymede. Now tonight, the moons will look a little different. I'm going to zoom out a bit and then change the date to tonight. And zoom back in on Jupiter. And all the moons are on the same side now. Io is closer to Jupiter than it was. And now instead of Ganymede being the furthest moon out, it's the second closest. Now let's look at the moon. On July 26th, it was just about first quarter. This is when I got the images of it. Tonight, it is almost full and has moved quite a bit. Now let's take a look at the moon through the telescope. This is the view of the moon through the 8-inch Celestron Schmidt-Cassegrain telescope. These big dark spots on the moon are basaltic plains caused by volcanic explosions. They are called maria, which is Latin for sea. Because they are less reflective than the highlands, they appear dark, and early astronomers mistook them for seas. Most of the maria are on the close side of the moon. When you look through a Schmidt-Cassegrain telescope, like the ones we have at NKU, the view you see is reversed from what you see in the night sky. So I took the image of the moon, flipped it, and annotated it so that when you look at it, you can tell what you're looking at. I want to show you Mare Crisium, the smaller mare towards the edge of the moon. Mare Crisium, or the Sea of Crises, seems appropriate for the craziness that is 2020. I think that it looks like a flounder. Got the two little craters that kind of look like eyes to me, and then there's a little bit in the back that looks like a tail. Another cool fact is related to its size. Kentucky would only take 60% of Mare Crisium. It's 1.7 times larger than the state of Kentucky. One really cool feature that I discovered while analyzing my photos is Rima Ariadaeus. Rima Ariadaeus is by Mare Tranquillitatis, or the Sea of Tranquility. Rima Ariadaeus is a linear rail. Astronomers think that it formed from tectonic activity when part of the moon's crust sank, making it a fault trough. It's 186 miles long. That's the straight line distance from Haile Planetarium to Evansville, Indiana, or just short of the driving distance from the planetarium to Jellicoe, Tennessee on the border. It's also the distance from Haile Planetarium to COSI in Columbus, and then to Boonshoft Museum of Discovery in Dayton. Both COSI and Boonshoft also have planetariums. To drive that distance would take you 3 hours. It also gives you an idea of scale of the moon size. Here are some more cool pictures of the moon. Now that we've seen Jupiter, Saturn, and the moon, let's take a look at some constellations. The brightest constellation in the south is Scorpius, the Scorpion. So here's the tail of the Scorpion. It wraps around, goes up into the body. And you see that big orange star? That's called Antares. It's the heart of the Scorpion. We're gonna go up to the head and claws of Scorpius the Scorpion. Antares is what we call a red giant. A red giant is a star like the sun when it's at the end of its life. The sun will eventually become a red giant, but we're talking about 5 billion years from now, when it runs out of hydrogen in its core. When the sun becomes a red giant, it's going to swell up. It'll swell up so much, it'll swallow Mercury, keep coming, Venus, Earth, and Mars. It'll go all the way out to the orbit of Jupiter. That's a really big star. It's the reason we call it a giant. Next to Scorpius is the constellation Sagittarius. The brightest stars in Sagittarius trace out a teapot. Here's the handle. Here's the body. Here's the top of the teapot. And this triangle on the front is the spout. So it's a nice little teapot. Those aren't all the stars in Sagittarius, but it's what we call an asterism, which is an easily recognizable shape in the sky. This asterism only includes some of the stars in Sagittarius, but there are asterisms that include stars in different constellations, and one that includes all of the stars in a constellation. In Sagittarius, there are a couple of interesting deep sky objects. The first one we're going to look at is M22, a globular cluster. Just above the moon here. Go back to M22. Find it. Yep, let's zoom in on M22. This group of about 70,000 stars is orbiting the center of our galaxy. And the stars are primarily old stars. Let's see what M22 looks like through a telescope. Another deep sky object in Sagittarius is the Lagoon Nebula. The Lagoon Nebula is on the other end of the stellar life cycle from Antares and all those old stars we saw in M22. Isn't it gorgeous? This is a cloud of mostly hydrogen gas that is collapsing down and forming stars. It's a stellar nursery. It's the only star-forming nebula visible to the unaided eye in the northern hemisphere besides the Orion Nebula. Through a telescope with a long exposure, you can even see color. The red is from all the hydrogen. Rising like steam from the teapot is the Milky Way, our galaxy. Here's a picture of what the Milky Way looks like from Cohen Lake State Park, taken by June Lau. or the Cincinnati Astronomical Society. We are going to move up the Milky Way until we come to this area that has 3 bright stars. These 3 stars make up another asterism called, you guessed it, triangle, the Summer Triangle. This asterism is made up of stars from 3 different constellations. You have Vega in the constellation Lyra, Deneb in the constellation of Cygnus the Swan, and then Altair in the constellation of Aquila the Eagle. So here is Lyra, the harp, which I think looks more like a tie or maybe a fish, especially if you include this star when we turn off the asterism lines. So I include this star in Lyra, and then it looks like a tie or fish. This actually does look like a swan. Deneb means tail, and it's the tail of the swan. Alberio is the head, got a long neck and body and wings. And then Altair is Aquila. And if you connect these parts, it's supposed to be an eagle, but I don't see an eagle. I usually see a stingray. So I think it's a stingray, Aquila the stingray. Goes along well with Lyra the fish and Cygnus the bird. And these all go along well with my favorite constellation right here, this little one. It's cute. I think that's why it's my favorite. And it's also pretty dim, so you have to be in a fairly dark place to be able to see it well. This is Delphinus. Delphinus, the dolphin. Now in the constellation of Lyra, there is a neat object known as the Ring Nebula. This is the next stage, or what happens after a red giant. Got the Ring Nebula. And it's a little tiny ring. It's the atmosphere of a star that completely ran out of fuel. So when our sun runs out of fuel, it will puff off its atmosphere as a planetary nebula, and the core will be left as a white dwarf. The blue-green color that you'll be able to see on my image taken through the telescope is from oxygen. Here's what the Ring Nebula looks like in Stellarium. On the other side of Lyra from the triangle is Hercules. This here is Hercules. And this part here the smaller part. Hercules kind of looks like a butterfly. The smaller wing here is another asterism known as the keystone. Hidden within the keystone is the Hercules globular cluster. This globular cluster, and Hercules here, has 300,000 stars. We're going to continue our journey to the other side of the sky and look in the north. So here we are facing north, and there's a pretty bright star pattern you should be able to recognize here. It's another asterism. This is the Big Dipper. So I've got the Big Dipper. It's part of the constellation of Ursa Major, the Big Bear. To add the rest of the stars in Ursa Major, I'm going to color them yellow. You go further on from the Dipper, you've got another set of 2 stars here. And then one more up top. So Ursa Major is the Big Bear. I like to think of this part as you've got the nose, the head of the bear with his nose out here, and then his body. And then coming down from the front, he's got a leg. And then in the back, he's also got a leg. And I believe these 2 stars as well. Different people connect them in different ways. So this is the Big Bear. And which includes the Big Dipper. Now we're going to use the Big Dipper to find other constellations. So if we take these 2 stars here at the end of the Dipper, this one here, and that one, if we draw a line between them and extend that line up here, this way, we get to Polaris. Polaris is the end of the tail of the little bear, the end of the handle of the Little Dipper. These 2 stars in the Big Dipper are called the pointer stars because they point to Polaris. Now, the Little Dipper is another asterism that is the same as a constellation. So you have these 2 stars, and these 2 stars at the end and Polaris are about the only parts of the Big Dipper that you can see, unless you're in a fairly dark area. But that's the big and the little, this is the Little Dipper, which is also all of Ursa Minor, the little bear. Funny looking bears though, because they have long tails, and bears don't really have long tails. Okay, now I'm going to move the sky because we're going to use the Big Dipper to find some more constellations. I'm just going to turn on the constellation lines. Asterism lines. We're going to take the Big Dipper. So we've got the handle of the Big Dipper here, and we're going to follow this curve of the handle. You see how it kind of curves? We're going to follow that curve, extend that curve out, and arc to Arcturus. So here's Arcturus. It's in the constellation of Bootes, and I think Bootes looks like a kite. So you've got the end of the kite, and it gets wider, and then it goes up to a point. And so it could either be a kite, or it could be many things, or maybe it's an ice cream cone. And I kind of like the ice cream cone interpretation, because if you look right next to it, you've got this C in the sky. This is Corona Borealis. And I like to think of it as a second scoop of ice cream that we are putting on top of our ice cream cone. So we get all the ice cream. So that's how I get from the Big Dipper to Arcturus and Bootes, then over to Corona Borealis, the northern crown. And Corona Borealis opens up towards Hercules. So this is Hercules. And then once we get to Hercules, we're back to our summer triangle with Vega. So now we've come full circle, and we will end this star party by looking at Comet Neowise. It's getting faint enough now, and the moon's out. You have to use optical aids to find it. Here's a picture of when I saw it a couple weeks ago in the morning sky. And then I'll show you one I saw it when I saw it in the evening, and when I saw it through the telescope, and some that Jun Lao took last week. He takes much better pictures than I do. They look amazing. Thank you for joining us tonight. Now, get outside on a clear night and go see the sky for yourself. Bye.